Okay, so just a reminder here, whenever we're trying to graph something, we need to get y alone. Remember, we need it in, if you will, slope-intercept. We need it in slope-intercept. So we need y alone. Okay, and that's going to be crucial. So that's actually our first step. Our first step is to get y alone. Okay. The next one, this is kind of a two-parter, is we're going to graph the line. You may be thinking, but how do I do that, right? So it's going to work the same way we graphed other equations, except there's some minute differences here. Because instead of an equal sign, we have that inequality sign. And the line itself could either be dotted. So the line itself is either dotted or solid. So it's either a dotted or a solid line. If it's less than or greater than, it's dotted. So if it's not equal to, it's dotted. If it is less than or equal to or greater than equal to, it is a solid line. It is a solid line then. So that's really important. The difference between dotted and shaded. Dotted and solid. Okay, if it's got that equal to sign, if it's got those equal to signs, then it's solid. If it's just regular, then it's just dotted. Okay, now after the dotted versus solid, then you need to shade your graph. So the next step is to shade. And you may be thinking, what does that mean? So shading means we're going to draw our line. So we would draw our line and we would color above or we'd color below the line. You may be wondering, well, how do I figure that out? So if it's greater than or equal to or greater than, then you shade above. So you shade above the line. If it's less than or equal to, we shade below the line. So we shade below the line. Okay? And then our last step, which most of you are going to hate, is going to be check your answer. And what we mean with that is that you're going to take any point where you shaded and plug it back in to make sure that it is correct. So any point in shaded to check. Okay, so I know that was a lot of confusing steps, but let's go through them together in example 1. All right, so looking at example 1, we first need to get this y alone. So the first thing I'm going to do is to move that x over. So I get 2y is greater than negative x plus 4. Now I need to divide both sides by 2. Y is greater than negative 1/2 x plus 2. And now we graph like normal. We're going to start at our y-intercept at our 2. We're going to go up 1 over 1 to the left. Up 1 over 2 to the left. Up 1 over 2. I would just put your dots right now. Okay, so now we've graphed this line. Make sure it's a negative. That's why we're going to the left. Now, before we said we need to figure out if it's a dotted versus a solid line. If it was less than or greater than, it was dotted. If it's less than or equal to or greater than or equal to, it's solid. So since we have a greater than symbol, our line is not solid. So I would just draw a line between your dots. You're not connecting them because it's a dotted line. Okay, you could also draw your line and then erase some parts, whatever. I just kind of connect my dots as best I can. But make sure you have some spaces in your line. So make sure we have some spaces in our lines. So let's make our lines a little more defined. Okay. If you go too far, just erase a little bit. Okay, not a big deal. So I'm just erasing mine a little bit. Okay. Then, now we need to shade. We said if it's greater than or equal to, we shade above the line. If it's less than or equal to, we shade above the line. So it's going to be helpful since this is greater than, I know I have to shade above the line. So it might help to draw these little arrows here because eventually we're going to be graphing 2 of them. So I would draw those little arrows and then I'm just going to shade above. So I'm just going to color in above the line. So if you want to shade with your pencil, you want to get colored pencils and shade, whatever. Okay, so for these first couple, I would just probably use my pencil. And then once we get to graphing systems, that's when I would start using colored pencils. So our last step is to check our work. So you're going to grab any point. Any point. I'm going to use the point 0, 3. Okay. I'm going to use the point 0, 3. And I'm going to plug that back in. Okay, it doesn't matter if you plug it back into the original or the new one. We'll just say, kind of always go with the original. So I get 0 plus 2 times 3 is greater than 4. Is 6 greater than 4? Since it is, then we know that we shaded correctly. If you get something that's incorrect, that's when you know you shaded wrong. Okay, so let's do one more together, example 2. Okay, we're going to do example 2 together. Okay, so we already have y alone, so we don't need to worry about that. So now we just graph. So at y equals 1, we know y, this is x, and this is y. So we know it's here. It's this one straight across. But we also know that it's less than, so it's a dotted line. So it's a dotted line, so it's going to look like this. I'd have some spaces in my line. Okay. And we know it says y is less than. So less than means we shade down. So I'm going to shade down and below and color that in. It doesn't need to be perfect. Just kind of scribble it. Okay, just so we know we can shade. Then again, we need to check our work. So we're going to pick any point. I'm going to pick the point 0, 0 to plug in. So is 0 less than 1? Yes, it is. So I know that I shaded correctly. So I want you to pause and try example 3. Okay, so hopefully the only thing here with this one is just to understand that this is saying x is greater than 2. So that means we need to, instead of shading up, you really shade to the right because those are the x quantities that are above 2. Okay, so now let's look on the back here. So let's look on the back. So looking at example 1, really the only difference is that we're just graphing both on the same graph. So I'm going to have to get them both equal to y. This first one's already equal to y, so I'm just going to graph that. I know it's down 3, up 2 over 1, up 2 over 1, so on and so forth. Since it's equal to, it's a solid line, and since it's greater than, it goes up. So it's a solid line. That means I graph above the line. So above the line means I'm going to be graphing to the left here. Okay, because those are the y values above that line. The second one, to get y alone, we have to subtract x. So get y is less than negative x plus 4. Again, start here. Down 1 over 1, down 1 over 1. This is a dotted line, and it's shaded down. So it's dotted. So I would just kind of draw some lines in between these. And it's shaded down. So it's when our y values are lower. So we're going to shade down. So now we're going to shade both of those. So I'm going to first start by just shading my red. And that goes this way. Then I'm going to shade my blue, which goes this way. And if you notice, there's an overlapping portion. That overlapping portion is actually our answer. So this overlapping portion is actually where our answer is. So our answers lie somewhere in this overlapping section. So if you're using a pencil, I would just shade this overlapping part darker. Now what we're going to do is we're going to check our work. So if you see 0 zeros in that part, so I'm just going to plug in 0 for both of these. So 0 is greater than or equal to -3. 0 plus 0 is less than 4. Since they both are true, then we shaded correctly. If one of them's not true, then we shaded incorrectly. Okay, or if they're both not true, you shaded incorrectly. So that's a good way to tell if you shaded incorrectly, is to check your work. So this is a crucial step right here, crucial. All right, let's look at example 2. So for example 2, we need to solve both of these for y. So I'm going to solve this first one for y. I get -y is greater than -x plus 2. Divide by -1. Remember, when I do that, I flip my sign. Now I get x minus 2. So I'm going to graph that in yellow, just so I don't confuse myself. So I'm going down 2, up 1 over 1. Now it's a dotted line, and I know I shade down. So it's dotted, and I'm shading down. Okay, so down means like this way. So if it helps, draw those little arrows. I always do. I think that's really helpful. Now I gotta solve for y. 2y is greater than or equal to -x plus 4. Divide by 2. Y is greater than or equal to -1/2 x plus 2. So go plus 2, up 1 over 2. We know that this, hopefully we know that this is dotted and goes up. Sorry, not dotted. Is solid and goes up. Is solid and goes up. So it's a solid line. That's my bad. And we shade above. So I'm going to shade now. We know this side goes down. This side goes up. So where they mix is right here in the middle. So I'm going to take the point, whatever this point is, just 1, 2, 3, 4, 5, 6. I'm going to take the point 6, 2, and I'm going to plug those in again back into the originals. So we get 6 minus 2 is greater than 2. 4 is greater than 2. So that first one is a yes. Gonna test the second one. And I have 6 plus 4 is greater than or equal to 4. 10 is greater than or equal to 4. So that's also a check. So now we know we shaded correctly because we used that point right there, the check where we shaded. Okay, so try example 3 for me. Okay, so hopefully you graphed them. You can plug in any point. I simply plugged in -2, 0 in to check them. Okay, it doesn't matter which point you plug in, any of them work. And I noticed that both of them checked out. So then my work is correct. So again, this is a crucial part to make sure you got them right. If it helps, Always tell me if it's shaded and where it goes. Sorry, solid or where it goes, or dotted and where it goes. If it helps to draw these little arrows, do that. Okay, if it helps to use multiple colors, do that. Okay, whatever you need to help learn this. Okay, so this section is long because you're not only graphing inequalities on lines, but you're also graphing systems of inequalities. So it's a double header here. Okay.